This is a video about force vectors. Forces are what cause motion in the human body. They could be external forces like gravity or friction or a force from a surface, or they could be internal forces like muscle forces and forces due to ligaments and tendons. A force vector will be denoted with a half arrow when I draw it. Your textbook will use a line underneath the symbol to indicate a vector. And sometimes a textbook will use bold-faced print to indicate a vector quantity, or you may see a full arrow above the symbol. Vectors are different than scalars in that they have both magnitude and direction. So if we draw an arrow like that to represent this force vector, the tail is this end, the tip is this end. The tail is the point of application of the force. So if this were a muscle force, that would be the point on the bone where the muscle inserts. The line of action of a force is going to be an extremely important line. This is a mathematical tool that we draw, and it will be used when we need to calculate the rotational effect of a force. So we will be drawing lines of action as long as we need them in order to calculate what are called torques. Now, the way we mathematically determine angles is if we have a force that's written like this, 300 newtons, that's the magnitude, that's the length of the force vector. 40 degrees is the angle. The convention is that you start on the x-axis and you rotate counterclockwise through the angle that indicates its direction. If you're in a different quadrant, like maybe you're down here in the third quadrant, you still start on the x-axis and go counterclockwise. And so that angle may be something like 240 degrees. And these are the angles that your calculators will understand. If you were to try to calculate a cosine or a sine of 240 degrees, your calculator would know where you were. Okay, so another important thing about forces are when you have multiple forces acting at one point, we're going to want to add them up. So if you graphically represent the sum of forces, what you do is you draw the forces tip to tail. So you would draw the first force, the second force on the end of that, the third force on the end of that, and your resultant is from where you start to where you end up. And that resultant is called the sum of the forces. And beware that this is a vector sum. This is not an algebraic sum. So if these forces had magnitudes of, say, 8 newtons and 4 newtons and 6 newtons, their sum is not equal to 8 plus 4 plus 6. I mean, you can see that the length of this resultant is definitely not 8 plus 4 plus 6. Okay, the only way the resultant would equal that if all these forces lay in one line. So we need different rules for adding up vectors. And in order to do that, we define what are called components. Very important concept. We're going to be doing this a lot. So a component of a vector means that you resolve the vector into two parts. And the two parts are perpendicular to each other. So this force is doing two things. It's pulling to the right, but it's also pulling up. And the x component is the part that pulls to the right, and the y component is the part that pulls up. Now, you could draw the y component over here. You will see that in some videos. That's okay. It has the same magnitude in the same direction. Doesn't matter whether you draw it on the end of fx or you draw it out of the origin. You almost never see fx drawn up here at the top, but you could do that too. So we've now generated a right angle triangle, and we know how to deal with the trigonometry of that using sine, cosine, and tangent. So we know that the cosine of the angle is the adjacent side over the hypotenuse. The hypotenuse is always the magnitude of the vector, the strength of the force vector itself. And the sine of the angle is the opposite side over the hypotenuse. And so this leads to equations for the x and y components of a vector. The x component would, in this case, would be f cos theta, and the y component would be f sine theta. Now, it's not always f cos theta and f sine theta. It depends what angle you're given. So you should be able to flip around and use different angles and use sine and cos appropriately. So if the vector were here, and perhaps you're given this angle, that's 40 degrees. Well, when we draw our x and y components and make our right angled triangle, x component is, now it points left. This would actually be a negative number. And the y component still points up. But notice how this 40 degrees is not inside our right angled triangle. We need to put it inside the triangle. And it goes up here. That would be the 40. The one down here next to the x-axis, that would actually be 50. Now, if you knew it was 50, you could use that and use the cosine with fx. But you may as well learn that if the triangle gives a different angle, it now gives the 40 up here. Fx is still always horizontal, Fy is always vertical. Now the cosine of 40 is the close side, which is Fy, the adjacent, and the sine is the opposite side, Fx. And so this leads to different equations for Fx and Fy. So you have to be adaptable and know, simply really know your trigonometry well and just use the cosine and sine appropriately. Now, sometimes we will also want to find the vector given its components. So say we're told that the x component is 3 newtons and the y component is, say, 4 newtons, and we want to know what is the length of the vector itself and what is the angle. We use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. So the hypotenuse squared is the sum of the squares of the components. Or take the square root of both sides. Magnitude is always a positive number. Components can be positive or negative, whether they point left, that would be a negative fx, or down, that would be a negative fy, but magnitudes are always positive. And if we wanted the angle, we see that the tangent of the theta is equal to the opposite over the adjacent. And so the angle itself would be the arctan of Fy over Fx. And so that is how you would find the magnitude and direction given its components. Now, there's a pretty good video on using components to add up vectors that I've linked in your reading assignment that you will watch next. And that should do it.